So last time on Monday, we talked about how we had these different things called permutation, combination, as well as the fundamental accounting principle, factorials, all of that. And what was our difference between permutation, the P, and combination, the C? What was the difference in the definitions of those? Brady?
The P, it does matter, and then the C doesn't matter.
And what does and doesn't matter? You're right, Brady, that something does matter. The order things are in matters in a permutation, but they don't matter in a combination, okay? And we're going to go dive a little more into that just right now as we cover this one page. And we're just going to do, we're going to go through every question, but we're not going to go all the way through every question. Does that make sense? Yeah. Okay. So we're going to try and figure out, how do we know whether or not the order matters from the words we're given? Okay, so we're going to try and interpret that now, so that way we can better know which formula is set up, because they're different formulas. Because a combination formula divides by more, because you have to make the number smaller. So this first one, how many ways can 4 candy bars be chosen from a store that sells 30 of them? Well, let me ask this, for whether or not the order matters. If you grab one candy bar first, is that different than having the candy bar at the end? Or if you grab the candy bar fourth, do you still have the same candy bar at the end? Yeah, so does it matter whether you grab a candy bar first or fourth? Does that change anything in reality for you? No, because you're still walking out of the store with the same 4 candy bars either way, right? So does the order you grab them matter? No, it wouldn't here. So this would be a combination. So what would the N be in this scenario? 30, because we had 30 total things we're choosing from. A bit of a refresh there. What would our R be? How many things are we choosing? 4. So this becomes 30. Choose 4. A reminder of how that's set up. You do N factorial on top, so 30 factorial on top. Yep, I'll get you one in a moment. And then divided by R factorial, so 4 factorial, parentheses, N minus R, 30 minus 4, parentheses, factorial. And that's our setup. The P, the permutation setup, is almost identical, but what isn't there in the permutation setup? I heard it? The extra 4 factorial at the start of the denominator, right? That's not there in a permutation, okay? Now, what would you want to do here on your calculator to make sure you get this correct? Parentheses around the entire denominator, okay? That's going to help you get it set up. $27,405. If you did not get that, raise your hand now so I can help you get that. Okay? If your calculator doesn't show this right now on your screen, I need to know that so I can help you get this on your calculator, okay? Okay. Ava, let me know if you do or don't get it, okay? All right. The next one. How many ways can 13 students line up for lunch? Well, let me ask you this. Will the order matter that the students line up in? If the students line up in a different order, is it a different way to line up? Think back to kindergarten here, when you guys lined up for lunch. Did you really care? Did you care what order you were in?
Yes.
You totally did. You totally did.
Your class didn't have numbers? No.
I mean, we did, but we didn't follow them.
I did.
You sit by your friends.
Okay.
They had to.
Well, a lot of people probably also wanted to be first in line, right? So they go to lunch first. Okay. I know some. Come on. I'm not that much older than you guys for that. Like, I know I'm ancient and all, but still. Okay. The order definitely mattered.
I just wanted to stay
What?
with my friends.
9 years and some people. Like,
All right.
That are 18-year-old.
So, what's our N here? How many students are there total? And is our R going to be like 12, like every student but one goes to lunch? No, it's going to be 13, right? Wouldn't that be just cruel? So it's going to be 13, permutate 13. Do we have a shortcut when we have that, Isaac? Yeah, it's just NPN, which is N factorial, so 13 factorial, which is still a big number. Can you tell me what number this ends up being with 13 factorial? Jaden?
Oh, hang on, look at it. 622702080. Didn't really feel like actually.
Can somebody read it to me now? That we have it written down. Can somebody read that to me?
I don't even know what place that
It's a little easier with commas. Eli?
6,227,020,800.
That is correct. 6,227,000,000, 20,800. If anybody didn't get that, let me know. Yeah, Elijah?
Are we going to have to write the commas down with our answer, or can we put the numbers?
You do want your commas. Yeah, commas will help. So reminder for commas, how do you do that, guys? Yep, you go to the end, count 3, comma, count 3, comma, count 3, comma. Every 3 you put a comma from the end. Okay? Number 3. How many ways can you make a 3-letter arrangement out of the letters in the word trapezoid? Do we think the order matters here?
Yeah.
Yeah, I'd say so. Here's a good example, guys. Put it to the test. If I do the first 3 letters, T-R-A, and I do the same first 3 letters in a different order, would we consider those different arrangements? Yeah. So if that changes it, the order matters. If we wouldn't consider that different, the order doesn't matter. Does that make sense? Okay. So like with the candy bars, if I said, okay, I got Snickers, Butterfinger, I don't know, Reese's, and Twix. But when I say them in a different order, does that really change what candy bars I got? No, that time it doesn't. But here, it would, because it's a different 3-letter word, a 3-letter arrangement. So I want your help in setting this one up. How would I set this one up?
N equals 3, R equals 3.
Not quite. N equals something else, but R does equal 3.
N equals 9.
N equals 9. How do we get 9?
Because the trapezoid has 9 letters.
Because trapezoid has 9 letters, right? There's 9 total letters to choose from.
And then it's 9p3.
Yep.
And then it's 9 factorial over, in parentheses, 9 minus 3, parentheses, factorial.
That's exactly right. Very good, Courtney. Very good, Elijah. So that's exactly correct on that. 9 factorial over, in parentheses, 9 minus 3 factorial. Now, could we type that into a calculator and let it do the work?
Yeah.
Sure, I'm not going to make us do that right now, okay?
What's the answer for it?
It is 504.
Okay.
Do you guys feel comfortable setting these up or no? Okay, a few of us do, a few of us don't, okay? We're going to practice setting up a couple more of these, and then I'm going to have us just go through the P and C part, okay? How many ways can you choose 2 books from a shelf of 40 books? I want you to write down in your paper whether you think it's P or C, permutation or combination. So remember, permutation, the order matters. Combination, it doesn't. Good way to think about it is if you flip them around, will it change anything? All right, who has an answer they want to throw out there? Okay, Brady? I would agree with you. I think it is a combination, okay? The order will not matter for this. We are choosing them. Choose is often a keyword for us. There's a few times where it won't be, and I'll talk about that in a moment, actually. But if I grab, let's say, a Harry Potter book first, and, I don't know, a Percy Jackson book second. Is that any different than me grabbing a Percy Jackson book first and then a Harry Potter book second? Do I still have the same 2 books at the end of the day? Yeah, so is there any difference? No, it really doesn't matter, because either way I'm grabbing 2 of them. So if you can say, hey, I can flip the order around and it won't change a thing, then it's not going to matter. I want you to take a second to try and set this one up. Look back at previous examples that are similar. All right, so our N is going to be 40. Our R is 2. So that gives us 40, choose 2. Ava, what's my equation or formula look like here?
40 factorial divided by 2 factorial in quotations 40 minus 2 factorial.
Very good, very good. So 40 factorial divided by 2 factorial parentheses 40 minus 2 factorial. Any question on that? Now we could go farther and say, hey, that's 780 after we type it in our calculator. I'm not making us do that right now. Number 5. How many ways can 12 swimmers finish in first, second, third place? Going right down whether you think it's permutation or combination, whether or not the order matters. All right, what are we thinking here? Brady?
Go to P.
Okay, I agree. Permutation. If they are in a race or competition, are you trying to win? Probably. Okay, is there a difference between first, second place, and second and third? Yeah, there is. So the order definitely matters here, okay? Can somebody help me set this one up? Okay, go ahead, Courtney.
N equals 12 and R equals 3.
Mm-hmm.
And so 12 factorial divided by, in parentheses, 12 minus 3. And then factorial.
Very good, very good, very good. And this is 12p or 12 pick 3. Questions on that setup at all? Okay, yeah.
Why aren't you factoring out another number like you did in number 4?
So number 4, it wasn't necessarily that we factor out another number. It comes down to those earlier in the notes for our combinations. The formula for combination is that you take n factorial divided by r factorial parentheses n minus r factorial. Whereas the formula for permutation is n factorial divided by n minus r factorial. So there's just a difference in the formulas for permutation versus combination, where permutation doesn't have the extra r factorial, whereas combination does. So that's the difference there. Did that answer your question? All right, good question. Any other question on that?
Do you know what the answer is to
1,320. All right, continuing on. I want you guys to try to do number 6, P or C on your own. Permutation, combination, do that on your own. Combination. Beth, do you think it's a permutation or combination? Okay, I'd agree with you. It is a combination, okay? Keyword here is that Miss Sullivan's choosing. And at the end of the day, if they're picking up calculators, if they're both doing the same task, does it matter which student she picks first or second? No. Now, what about if she was giving them different tasks? What if I say, hey, Jocelyn and Jack, could you wipe down desks, and Jack, could you wipe down calculators? Would that be different tasks now? Sure. So that's a different scenario where the order does matter. So if I were to switch it around and say, hey, Jack, can you wipe down desks, and Jocelyn, can you pick up calculators? Is that different than the other one? Yeah. But if I say, hey, can you two wipe down calculators? And I say switch around, hey, can you two wipe down calculators but say them in the opposite order? It doesn't change anything. It's still the same two, doing the same job. All right, let's go to number 7 here.
Do you know what the answer to that one is?
Number 6, the answer was 351. 702, you forgot the extra 2 factorial there because it's combination, not permutation. 7, you have enough tickets to play 6 different games at the amusement park. If there are 14 games, how many ways can you choose 6? So permutation or combination?
No.
It's going to be a combination, okay? Key is, a couple keys here. One is choose. Second thing, if you ride 2 rides in a different order, let's say you go on the Ferris wheel and then you go on the, kind of like the teapot kind of ride. You know what I'm talking about, a teapot ride? Like a Disney World, like where you get in the teapots and you spin like crazy and it makes you want to puke. Okay? I don't like that. I don't like those rides. But I'm more of a roller coaster type person. Anyway. Does it change what rides you rode if you do the teapot first instead of the Ferris wheel first? No, either way you still rode both rides. So the order doesn't matter there. How many different ways can 9 trumpet players in the marching band line up? Raise your hand if you're in band. Okay, Josh? Anyone else in here in band? No way. Josh, are you really the loner in band in here? That's surprising. All right. Isaac, you're in band, aren't you?
Me and Jocelyn both quit last year.
Oh, okay. Okay. All right. So does the order you have to line up in band, does that matter, Josh? Yeah, it does, right? Okay. And typically, in band, you want your you want your best player in a prime spot so they can be heard the best, right, Josh? Okay. It's normally called first chair. So the order does matter. This is a permutation, okay? Order definitely matters. Kind of like a sport when you line up people in a different order, different positions. Same idea. All right. 7 students work together on a project. How many ways can their teacher choose 4 to present the project? Permutation, combination. What are we thinking here? Alice, what do you think? You think it matters? All right. Why do you think it matters? Okay. Now, let me ask this. I get where you're coming from. Let me frame it this way. Does it say the 4 people have different roles, or they all kind of have the same role while presenting? Okay. So would it matter who's picked first, or if that just the 4 people are in it? Just the 4 people are in, right? So there, the order doesn't necessarily matter, actually, then. Okay. So I get what you're saying. But I want us to think about it a slightly different way, okay? So the order won't matter. It's going to be combination, okay? Now, what if, though, it said 4 people to present? 1 to click through the slides, 1 to speak, 1 to write the information down, and another person to do this. Like, would then the order matter? Yeah, because they all have specific roles. But when they're all doing the same job, at the end of the day, whether or not this person was picked first or fourth, they're still part of the group of 4 that's doing the same thing. Okay? That's what we mean by whether or not the order matters. All right, there's 18 offensive players on the hockey team. How many ways can the coach choose a left wing, center, and a right wing to start the game? What do you say?
P.
It's P, permutation. Why?
Because they're different roles.
They're different roles. So even though it says choose, and we might see the choose and say, oh, it's combination. It says very specific roles for that choice. Because it's different whether someone plays left wing or right wing, whether someone plays center or a wing. My soccer team definitely knows that. All right. How many different 12-letter arrangements can be made using the letters in the word Indianapolis? P, permutation. The order does matter here, okay? If the order doesn't matter, it'd just be 1, because then you'd have all the 12 letters there. But the order does matter. If the I comes first, it's different than the N coming first. Or the D, or the P, or the O coming first. Last but not least, there are 26 goldfish in the tank at the store. How many ways can Ben choose 5 of them?
C.
It's combination, C. It doesn't matter what fish Ben picks first. At the end of the day, he's walking out with 5 fish. So whether or not he picks a fish first, third, or fifth, he still has that fish. That's what matters. Any questions on that, guys?
Could you, I have the answers for 7, 8, 9.
Sure, I'll read them off. I'll write them down real quick, okay? So 7, the answer ends up being 3,003. 8, the answer ends up being 362,880. 9, the answer ends up being 35. 10, the answer ends up being 4,896. 11, it ends up being 19,958,400. And then 12 ends up being 65,780. So, the back side of this page, because we did the front last time, right, for homework? Okay, the back side, I'm just going to ask you to do every other question, okay? So we have, let's see, thank you. 16 through 25, okay? Let's just do the evens. Okay? So let's just do the evens on the back there, okay? That makes sense? Okay. I'm going to give you guys about 5 minutes to get your feet wet on this. Okay? Before we jump into our next one, okay? That way it stays fresh right now for a moment before we move on.